All right, I'll do. You don't really need to do this for the project, but just to show you, since we did the modal, I talked about like maybe changing some of the beam properties to see if it can help bump up that first natural frequency. So let's try to do that. So I propose that if we use a different section for these bars here, that actually we can improve things. Okay, so if you remember previously, we used circular section, 1 inch diameter, right? So let's keep the areas the same, but instead of a circular section on those, let's use a rectangular section. So I got to do the numbers super quick here, right? So if it's a 1 inch diameter, that is a cross-sectional area of 0.785 inches squared, okay? So let's keep that the same, and let's say, okay, what if we use like a quarter as the small dimension? So I'm going to divide that by 0.25 divide. So that means that the same area would be a rectangular section okay, so it's a little extreme, right? But like I know let's see if you can see it. So if we use that cross section, right, it should be stiffer, okay? But it should have the same weight, all right? So let's do it. So I'm gonna have to make a new property. So let's go in and make a new property. We're gonna use P bar L again. So this is gonna be the square section, or rectangular section. All right, and let's make it a different color so I can make sure I put that in there. It's going to be a P bar L card, and the type will be, what is it, rectangle that we call it? Okay, yeah, that's fine. Oops. Tube I channel T box. Box, right? It's a box. No. Is it bar? I think it's bar, but I always forget. I always forget which is which. I'm assuming. Well, let's just double check. So I never know. So let's go, and I'm going to Google P bar L, and I'll get the Autodesk one always pops up, but they're all the same. So let's look at this card, right? So we want to do this one, a bar, and dimension 2 is going to be the, if we use the Y orientation is up, dimension 2 is the bigger dimension of 3 inches, and dimension 1 is the smaller. So it's going to be a type as a bar. Okay, so let's go back and do that. So bar, I'm just making a note on my little card. The cross section type is bar, and dim 2 is the 3.14, and dim 1 is 0.25, assuming the orientation vector is up, the Y direction. Okay, so let's go and change that. Right, bar, okay, and so the first dimension, dim 1, is 0.25, and then dim 2 is 3.142. All right. Now we're going to assign that to particular elements. So only the ones that are on the top and the bottom. So we're going to go to 1D. Bars. Now we're going to update them, and what we're going to update is the property. So let's change this to bar. Let's change this one. Wait. This one, 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 and this one. Okay, so we're going to C bar, but now the property is going to be the rectangle. And we'll change the orientation to Y just to make sure for all those is Y. And so we're going to update, and what we're going to update is the property as well as the local axis. Although I think I had them in the Y orientation to begin with previously, but this way we'll be sure. Okay, so that's what we have. So if we go and we shade these not by component but by property, right, we should see that those have a different property. Now, what's going to actually happen, I suspect, is it's going to still have, so we're going to move up this mode, but because we thinned it out in the X direction. Actually, what you're going to see is the lowest mode won't change that much, but it'll change to be the bending about the Y-axis. Because it might even actually drop. But anyway, we'll see. But it'll be a different mode. We'll bump up the bending mode in this direction, but we're going to bump down the bending mode in the lateral direction, okay? Okay, let's call it, I'm going to save this as something else. I'll save as, I'm going to call it example 3. And let's run it. So analysis, OptiStruct. We'll solve it. Okay, it's giving me an issue. What did it like? Incorrect data. Oh, did I not define a material? I think I did not define a material. I did not. Right, I didn't define a material, so let's change that. I did not add a material. So now it should be good. Okay, let's try it again. So far happy. I think it's good. There it goes. Let's look at the results. Let's see if my guess is correct. All right, so let's look at the modals. It reran it for everything, so the G analysis changes and all that sort of stuff. We can relook at those. But we were doing this just to see how we stiffen it up for the modal. So let's look at the modal analysis, subcase 4. All right, see, it did drop. So it actually, we ended up having a hertz before the first mode was 6.5 hertz. But now the first mode is dropped to 2.2 hertz. But I bet it's going to be the lateral mode where it's flexing about the y-axis, where it's flexing in the xz plane. And I will guarantee that's what it's going to be. Yep, and that's what it is, right? And that's sure enough what it is, right? You can see it's that. And that's because we really thin that up, okay? So, now watch. Let's see what the next one is. Let's find the one that was the bending. Okay, so you see the second mode is now also flexing in that lateral direction because it's so compliant. We get a twist. Let's see if we can find where that bending mode went. See, we still haven't found it yet. We're up to mode 5. Mode 6. Okay, so finally mode 6 is like the first bending mode that was the lowest mode before. But now that has bumped all the way up from 6.5 hertz to 150 hertz. So we've really stiffened that up, but by keeping the area the same, we significantly compromised it flexing in the lateral direction. So maybe something that's a little more squarish and not so extreme because, we did a 1/4 inch this way and then 3 inches that way. So that's kind of extreme, but maybe something more like, I don't know, 1/2 inch by, by like 1 1/4 or something like that, right? But, that's the type of stuff you can do with a modal analysis.